Of an absorber plate for solar air dryer using nickel oxide nanoparticle coating, supervised by Professor Dr. Mazharul Islam, and the examiners are Dr. Fazle Rabbi and Dr. Asad. And the students are Nahin Abedin, Jahidul Hossein Piash, Toibul Alam Opu. You have 20 minutes for your presentation and 10 minutes for question and answer session.
Assalamu alaikum. I'd like to thank our honorable faculty members giving us this opportunity to present our thesis, design of an absorber plate for a solar dryer using nickel oxide nanoparticle coating. This group is supervised by Professor Dr. Mazharul Islam. We are grateful for his keen supervision. I would like to introduce our group, myself, Jahidul Hossein Piash, ID 1701-08018.
I am Nahin Abedin, ID 003.
I'm Taibul Alam Opu, ID 051.
In the next slide, in introduction, we know sun is the main source of energy, and energy is now essential for all the living things of the planet, whether it is renewable or non-renewable. As world population is growing, so does energy demand is increasing day by day, and everyone is trying various techniques to harness the solar energy, and an absorber plate is a great collector of this solar energy. However, only 15% of our energy demand is made by renewable energy, and in 2020, around 7,13,000 megawatt energy was produced using solar technology. In the next slide, in our problem statement, we see an absorber plate is the most important part to harness solar energy, and because it absorbs the heat and increase the fluid temperature, and the more absorbability will the solar absorber plate will have, the more heat collection and higher temperature will get. So we can use different aspects to increase this absorbability or the final temperature. A coating can be implemented to increase the absorbability and the final temperature. In the next slide, here is our objectives of this thesis. First objective is to design an efficient solar absorber plate for solar dryers, and the second one is to develop a computational model of the absorber plate and carry out our simulations, and the third one is to conduct performance analysis of a solar dryer with the newly designed absorber plate. In the next slide, we have go through some literature review, and in literature review, we are the working principle of an absorber plate. We found a glass cover will provide insulation and reduce conventional losses for the absorber plate, and the tube will be made up of material with high conductivity, which will transfer heat from the absorber plate to the fluid. And flat plate collectors can be made more effective and efficient, and sorry, can you yes, and in some literature review, we find out about shape of the absorber plate. In the paper of B. Kundu, we found that rectangular profile plates have the highest efficiency among all the shapes, and it is also easy to manufacture. Also, 60 to 70% efficiency was investigated using flat shape absorber plates. In the next slide, so this absorber plate will be using in a solar dryer. A solar dryer is a device that uses the solar energy to heat and dry substance like food. And solar dryer are in two types. One is a direct type solar dryer and another is indirect type solar dryer. And this absorber plate will be used in an indirect type solar dryer. I would like to invite Taibul Alam Opu to carry on. the presentation.
Thank you, Nahin. I will carry out next phases. The most important thing for our absorber plate was the coating materials. To choose the exact perfect material for higher efficiency. And as we have gone through the literature reviews, we found some prospective materials, as you can see, nickel oxide, phase change material, or known as PCM, carbon nanotubes, and another one, SMMT. It's a industrial product, and it can be directly used as an absorber plate. It is manufactured by a Chinese company, and they have made it directly. There's no need to manufacture it. You just can buy it and place it in the absorber plate. And in the below table, we can see from different references that the materials shows different data that helps us to choose the better option. As you can see, the first one is 5% CNT, or carbon nanotube. It shows us 83.75% efficiency. But there's one problem with that it's manufacturing technology. We need ultra sonication technique for this material to embed it in a absorber plate. Our base material is aluminum, and we will coat with another coating materials with that. So the CNT, it has some complex processes that are not available in everywhere. So that's why we escaped it. And the phase change material, it's also an prospective material, but its efficiency is quite low according to Kabil. It says it's 70% efficient. That's why we escaped it also. The third one is very common, black chrome. From the earlier inventions of absorber plate, black chrome is popularly used, but the problem is its absorptivity and emissivity is quite low compared to others. That's why we escaped it also. And the SMMT absorber plate, it has a high absorptivity and emissivity, but the problem is the company only sells it with an bulk amount of that. So that's why if you want to embed it in an aluminum plate, you have to purchase it for a bulk amount. So that's a problem, and it's not easily available on everywhere. So that's why we also escaped it. And then we went with the nickel oxide particle. It's available, and also it shows some good data. It's high absorptivity and also emissivity according to Voena. That's why we went with the nickel oxide. Before starting the equations, we tried to do some simulations with some open source softwares like Inzel, dedicated for solar collectors, and another software, CodePro. But due to lack of some parameters, the results were not very good to show. That's why we went with the computational model. We used some series of equations and put some values in there available from the PVGIS, and we tried to show we tried to get the highest temperature of the absorber plate. It was our primary goal. As you can see, a series of equations, and equation number 2.13, this is our the most important goal, to get the maximum temperature of the absorber plate, so that it can be used in the solar dryer. Going on the next slide. This is an illustration of a solar dryer on the left side. Another of our thesis mates, they are working with the solar dryer, and a part of that, the absorber plate, we are only working with that and the coating materials of that. If I summarize a little bit about the solar dryer is a device, as Pierre said earlier, that can in this they can dry the foods using solar energy. There's a chimney on the up, and there's a solar panel also used to provide power for the blower in the front, and there is a control panel and battery, and the most important part, you can say, the absorber plate, which will harness the solar energy. On the right side, as you can see, it's a very simple observer plate. The rectangular profile was chosen through the literature review, as we saw that the rectangular profile gives the highest efficiency, and also we found that some of the authors or some of the writers, they use some textures on the upper surface, but they were not as efficient as a flat plate surface. So we went with the flat plate observer plate, as it shows the most prominent scopes for the future. Going on the next slide, that's our methodology. We first stated the problem. What was the problem? The problem, you can say that the existing absorber plates, the coating materials, they are not in a sense not very efficient. So if we want to improve that with the coating materials, we had to go with some new modifications. Then we did some literature reviews of the existing absorber plates with different coating materials, what they are using, and then we went with some design specifications. As in our case, we have chosen a flat plate solar absorber plate, and then with the equations, we did some performance analysis using Excel sheets using different parameters. And then we saw if the performance is acceptable or not. If we when we saw that the temperature is a bit low, then we again started from the literature. We tried with another material, and that's how after 2 or 3 things we got the nickel oxide for our thesis, and then we went with the results and conclusions. Nahin will continue the rest of the presentation. Thank you.
Assalamu alaikum, everyone. I am Nahin Abidin. I would like to begin with the design parameters of our components. So firstly, the absorber plate. The length and the width were chosen here on the basis of the available area of the solar dryer onto which our plate would be implemented. And the thickness was chosen 4 millimeters. We took this from the work of the reference number 11, where it was stated that the thickness of any absorber plate should be between 4 to 6 millimeters. 3 to 6 millimeters. And so we went with 4. And we will see a few slides later why a thicker absorber plate makes no significant changes. When it comes to the solar dryer, we have chosen the tilt angle and the azimuth angle as follows. And this is from the Global Solar Atlas, which is an online resource where we put the coordinates of our university as the working area or the working place. And it showed that this should be the optimum values. On the next slide, we can see the performance analysis. In the first table, we collected some values of the parameters, different parameters from different sources. These includes the absorptivity of nickel oxide, the insulation, the Stefan-Boltzmann's constant, and so on. The table below shows the validation of our work with the experimental results of Srividya et al. From India, which was conducted in 2019. So if we put this table into a graph, we can get this graph, which shows a bit difference between the two sets of data. So the reason behind this difference is that the work of Srividya et al. Didn't provide some of the environmental parameters, such as the wind velocity, the ambient temperature of the environment, and some more parameters. So what we had to do, we had to assume some of those values and try to make it as close or as realistic as possible to the actual experiment of Srividya. So for that reason, there were some differences in temperature as high as 15 degrees Celsius, as we can see from the graph. So due to this significant changes in temperature, we had to carry out sensitivity analysis to make sure we are not being left in anything. So at first we did 3 sensitivity analysis with the final temperature of the plate being compared with 3 things: the absorptivity of the plate thickness, and the wind velocity. So from the first graph, we can see as the absorptivity of the plate increases, the final temperature of the plate increases almost linearly. And The same goes for the plate thickness. However, as I was talking about earlier, the plate thickness makes almost no significant changes. The temperature stays 53 degrees Celsius, around 53 degrees Celsius, no matter the thickness. So if we go from 2 millimeters or up to 20 millimeters, the thickness almost stays, the final temperature almost stays the same. So thickness does not make a significant change. When it comes to wind velocity, the relationship is inverse. So as the wind velocity increases, the final temperature of the plate decreases. The reason behind this is given in the equations. I can elaborate them later if we have the time. Right now, I will move on to the social and the environmental related issues. As we know, United Nations have established some sustainable development goals in the year 2015. So according to us, we think these few SDGs are relevant to our project, and we would try to meet them as much as possible. So in conclusion, I would like to summarize our work. So primarily our target was to improve or increase the final temperature of the plate as much as possible. And for that reason, we had conducted performance analysis on Excel sheets using the Nickle model, who has provided us the equations. From the work of Johnson, we have achieved some parameters which we implemented in this model. And finally, we couldn't, unfortunately, carry out the fabrication from which we would have achieved a working model. So that was unfortunate because of the ongoing pandemic. However, we tried our best to make the computational model as realistic as possible with the working model. So that is all for our thesis. If you have any questions, you may ask. Thank you.
We have two examiners. One is, thank you for your presentation on this observer plate group. Two examiners, one is Dr. Fazlur Rabbi, and another one is Dr. Asad from Canada. Unfortunately, he's busy. He cannot join. Inshallah, I will send him the video for his evaluation. Dr. Fazlur Rabbi can continue, inshallah. Please.
ফজল রাব্বি মানে মিউট করা। রাব্বি তোমার মাইক মিউট হয়েছে, আনমিউট করতে হবে।
স্যার, হ্যাঁ স্যার, শুনতে পাচ্ছি।
Sir, you may ask any questions if you have.
Rabbi, as an examiner, you can ask question.
Sir, my microphone is, sir, just 1 minute, sir, please. Okay, Piyash, can you go to the slide where you're showing the two results comparison? Yes, here.
Yes, sir.
So can you explain why we are seeing the differences here? Like why the difference between the two results, your and the published result?
Okay, sir. So the main reason is that, as I've mentioned before, the work of reference number 14, CVV et al., they didn't provide any environmental factors or environmental parameters such as wind velocity, the ambient temperature, etc. in their work. So what we had to do, we had to assume what their ambient temperature would be or would have been in their time in that place in India. So the ambient temperatures that we have taken, such as 29 degrees Celsius, 30 degrees Celsius, these are all assumed. And according to these temperatures, we have taken the IT, which is the solar insolation from Global Solar Atlas, as in what insolation would be in this time at 9 o'clock in the morning, at 10 o'clock in the morning. So we have to assume this data. And then after inputting this data in our equations, provided by Nickle, we achieved these ones. So yes, there is this. This is the, I think this is the main reason why we can see this difference. Why we can see this difference.
And you have actually calculated this using an like a simulation in Excel. What?
Excel.
Yes. So did you look for any other ways that where you can actually simulate these results?
Yeah, yes, sir. There is a software called Code Pro, and there's another one called Incel. And however, those two didn't provide us with suitable results, primarily because they require some parameters which are unknown to us and also unknown or also not provided in the work of Srividya et al. So those softwares had even more parameters which we had no knowledge about. So this was the closest paper or article which we could relate to with our work.
Sir, I'd like to include something. The Incel, sir, the software that was we are initiated our work. That was dedicated for a solar collector, and inside the solar collector there was an absorber plate. So when we tried to carry out the simulations in that, we were missing some parameters of the collectors. As you can see, sir, we are developing a solar absorber plate, and we tried to find some of the dedicated software for just the absorber plate to input different material properties like absorptivity, emissivity, refractive index, like that. But unfortunately, we couldn't found that. That's why we went with the equations and Excels. The Nickle provided some good equations, and he showed some good results. That's why, sir, we went with the equations and we carried out the simulations in Excel.
Okay, thank you very much. I have no further questions. Thank you.
Thank you, sir.
Okay, thank you, Dr. Fazlur Rabbi. Anybody else has any other questions or comments? Prof. Dewan, you or anybody?
Assalamu alaikum, sir.
Yes, please. Dr. Harun, go ahead.
Actually, I have a very simple question. In your slide number, maybe methodology slide. Yeah, here, why it shows that if no, then it goes to the literature review. Why not the problem statement?
Thank you, sir, for question. So the problem is specific, sir. As you can see, we are trying to get the highest temperature of the absorber plate. So we are trying to find, sir, the prospective material for our absorber plate, and the prospective material can be found in the literature reviews, as we have selected some materials for that. In the problem statement, yes, sir, you have a valid point, but there, as you can see, we have chosen the problem that we need the highest temperature. That's why we didn't go in the problem. We back our circle from the literature reviews to find the what material gives us the most temperature or acceptable temperature. That's why, sir, our circle was again initiated from the literature review.
Actually, if you don't get the exact result, in that case, problem statement also can be changed.
Okay, sir.
You understand?
Yes, sir. Yes.
You can also modify the problem statement according to necessity.
Okay, sir. Yes, sir.
So I think you should consider this one. Okay, thank you.
Thank you.
Any other question for anybody? We have externals here. Rupesh Da or Zubair, you have any questions regarding this interesting topic? I know you have idea about this. Zubair or Rupesh Da? Okay. Prof. Dewan, you have any question for them?
The reflectivity index, how do you get this one? Can you explain?
Sorry.
How do you get this?
Yes, sir. So
On the
this was
reference.
taken from the work of Johnson et al. They have provided us with the reflectivity of the glass, the reflectivity of nickel oxide. So these parameters were taken from the work of Johnson et al. Reference number
Okay.
12.
No. What I am asking actually the glass. You said glass. So which sort of glass? Did you clarify that one? And there are different types of glass. Any
Yes, so there are different types, but
clarification?
we went with the one which Johnson had chosen. I can't.
You just pick that one, okay?
Yes, sir. Because we have the value known, so we didn't go for any other type of glass.
Another question, the time you said from 9 o'clock in the morning to 3 p.m.
Yes, sir.
So I think it should be a little bit more specific. You assume the temperature, ambient temperature.
Yes, sir.
29 to 35, it's a random fashion, you just pick that one. But there is some temperature profile in Dhaka city, you can pick that one actually. And
I
maybe
think the location is India, isn't it?
Yes, sir. The
Actually,
location is India.
actually, they got the data for that side from
that
Global
side.
Solar Atlas.
Okay,
Yeah,
then
that's
you
available.
should ambient temperature in bracket, you can mention the reference number.
Yeah. Actually, it's not clear. This is really, I think Prof. Dewan is rightfully, misunderstood like others, that it's not clear from here, but that you guys, you took it from, Nahin mentioned you took it from Global Solar Atlas, but it's not clear from this figure, yeah, how you're getting this data. So it should, in your report, make it absolutely clear that so that there is no confusion. Because this is based on something. Those are based on some data, right? For that location, that particular location in India, right? Yeah.
Yes, sir.
Okay, that's all. Thank you.
Thank you very much, Prof.
Thank you,
Dewan.
sir.
I think Prof. Dewan mentioned a very good issue about this glass. Yeah, and Dr. Rabbi Fazlur Rabbi had some comments. Try to address them. And another thing, I just want to add. You said you mentioned Code Pro, but I'm not seeing any output from Code Pro. Why? In Code Pro, you can change radiative properties, isn't it? Yeah. Why I'm not seeing any results from Code Pro? Yeah. So personally, what I want that you should include, because some of these things what you have done, those can be done in Code Pro. Yeah. Dr. Fazlur Rabbi also mentioned that why you are not using any available software, and this is what he indicated. So I think what you did, yes, Inzel I think you won't be able to change some of those things in the module, but in Code Pro you can change some of those radiative properties. And Professor Dewan was mentioning glass. Some of those things can be done in Code Pro, isn't it?
Yes, sir. Yes.
So I think you guys should do that. Okay.
Yes, sir.
Thank you very much. Thank you very much.
Thank you.